Hello YouTube. Mercury is the smallest and closest to the Sun planet of the solar system. In this world without an atmosphere, the surface temperature reaches 430 degrees Celsius during the day, and at night it drops to minus 180 degrees Celsius. Let's agree this is not the place where you can expect to find water. But no matter what, water is there. The North Pole of Mercury is a place where huge reserves of water ice are stored for the time being, as if waiting for the needs of future colonists. And the ice has a dark color because it contains a lot of organic substances. Organic substances. For the first time, astronomers discovered ice deposits at the North Pole of Mercury in 1991. They made the discovery during radar observations using the Arecibo radio telescope. As on the Moon, there are craters in the polar regions of Mercury, the bottom of which never receives the light of the Sun. The tilt of Mercury's rotational axis is almost zero, less than 1 degree. So there are pockets at the planet's poles that never see sunlight. Therefore, it is not surprising that many researchers assumed the presence of ice inside these craters. And where did this water come from? Well, to some scientists it's simple. It was brought by comets that collide with Mercury from time to time. So the issue is resolved in their minds. Therefore, when NASA's MESSENGER probe entered orbit around Mercury in 2011, one of its goals was to detect these deposits. The presence, which by that time did not cause scientists any doubts. However, it turned out to be quite difficult. See, the probe's cameras did not see the ice, and it was necessary to wait for data from the MLA laser altimeter to confirm that there is material with high reflectivity at the bottom of some craters, and this data should correspond to the information about the area defined by the Arecibo Observatory. But even this would not be the final proof. It was necessary that the NS neutron spectrometer and the MDIS camera also confirmed the existence of water ice. However, the MESSENGER's cameras suddenly discovered strange material at the bottom of the northern craters. Contrary to all assumptions, no ice deposits were visible in the images, and an unidentified dark substance was found instead. Researchers have previously assumed that Mercury's ice is mixed with surface regolith dust, just like on the Moon, and therefore it will be difficult to detect. But they never expected that the ice would be much darker than the rest of the surface. The craters of Mercury's North Pole are permanently shaded. The data is obtained from an MDIS camera and a laser altimeter. Well, anyway, but as if that wasn't enough, another mystery appeared. The bottom of many of the craters where these strange deposits were found had an average temperature of minus 150 to minus 50 Celsius, which is much higher than the equilibrium temperature of exposed pure ice, about 173 degrees Celsius. The answer to this riddle was the assumption that the ice is mixed not only with regolith, but also with dark organic substances that prevent its sublimation due to a layer 10 or 20 centimeters thick. And by the way, organic substances, give it a characteristic dark color. This is all fine and good, but where did this all organic matter come from? You know where Mercury is, where it's located. Okay, and how difficult its position is. Current theories suggest that it could have formed directly at the bottom of the craters under the action of energetic ions captured by the planet's magnetosphere, mainly solar wind protons. Well, you should also not discount the impact of cosmic rays. Among organic molecules formed in this way are aldehydes, ketones, ketones, alcohols, amines, and organic acids. Mercury's North Pole, therefore, may be the largest repository of complex organic substances closest to the Sun. How much ice are we talking about? It's hard to say, but the upper limit may be about 3 billion tons. This is about 3 mountains the size of Mount Everest, which is a lot for the planet closest to the Sun. For comparison, on the Moon it is believed that the amount of ice is 1,000 times less. And Mercury has not only dirty ice, but also clean ice. The data obtained from MESSENGER shows that at the bottom of some craters, such as Prokofiev, there are areas of the purest ice exposed to the vacuum of outer space. The study of these deposits of ice rich in organic substances is undoubtedly a very interesting goal. Unfortunately, the surface of Mercury is one of the most inaccessible places in the solar system from the point of view of the energy of flight, and yet the ice is there for those sentient beings who will be able to reach the planet, maybe to establish a way station on the way to other faraway destinations. I don't think our development at this point can imagine the needs of such a civilization, but we try. Now, the BP Colombo mission is currently heading to Mercury. The European and Japanese space agencies joined forces and sent it into space in 2018. The arrival of the expedition to Mercury is expected in the year 2025. The mission includes 2 orbiters which are designed to explore the surface of the planet closest to the Sun. There is even a small chance that the Russian Mercury P project will also be completed sometime in the near future and be sent to Mercury. I certainly hope so. The more the better. But besides black ice, there are a few more enigmas on the little planet. Having a massive iron core and the ultra-thin crust, the planet Mercury is a strange object of the solar system. There is a hypothesis that in the youth of the planet, a catastrophic collision deprived it of its outer layers. This allowed the heavy metal core to become the basis of Mercury. New research shows that the planet has received a powerful blow, or a whole series of blows or impacts. The evolutionary path that Mercury has taken is almost not found among other planets. When NASA's MESSENGER spacecraft arrived at Mercury in 2011, it found relatively high levels of sodium and thorium on the planet. Because these elements are quite volatile, they are expected to have been lost in high temperature events, such as giant impacts. According to the graduate student at the University of Zurich who researches this, her name is Alice Chow, and that's what she told the media. Puzzled by the data, Alice Chow and her colleagues modeled 3 different scenarios. Scientists wanted to find out which of them is the most likely explanation for the formation of Mercury. All scenarios took into account the properties of the detected elements. The formation of Mercury by giant impacts is possible, but it is an unlikely event, Chow and her colleagues reported in their paper. This statement is consistent with observations that were made while using instruments such as NASA's Kepler Space Telescope. So far, out of more than 5,541 confirmed exoplanets, only a few rocky worlds denser than the planet Mercury have been identified. Mercury is the smallest full-fledged planet in the solar system, but at the same time it is the second most dense, second only to Earth. Most of the planet consists of a giant core, which according to various estimates occupies 70 to 85% of the planet's volume. In 1988, researchers suggested that an unusually large core of the planet was the result of a giant impact. It stripped the planet of its mantle. But Messenger brought confusion to the collision theory when it was discovered when it discovered light elements on Mercury. Scientists began to doubt that high energies and temperatures generated by the impact left volatile materials on the surface of the planet, discovered by Messenger. However, in recent years, researchers have begun to question their assumptions. They began to accept the fact that the elements that are present on Mercury could withstand a catastrophic impact. Collisions were a frequent occurrence in the early stages of the formation of the solar system, according to Chow. The results of the stimulation are as follows. It is almost likely that the planet Mercury was formed as a result of two collisions. They occurred at an angle of 28 degrees and a speed of about 20 kilometers per second, according to the researchers. The time interval between collisions also played an important role in the process. After the release of the material, it takes about 1,000 years for the debris cloud to cool down and settle on the planet. As each collision affects the next, the hot cloud of material surrounding the battered Mercury after the first collision affects how much material the planet can eject. If Mercury had time to cool down between impacts, it would have retained most of its materials. So the more collisions occurred over time, the faster Mercury lost its mantle, according to Chow. So is the scenario according to which Mercury was formed established? Researchers are not sure about this. Each of the simulated scenarios requires special conditions, and each of them has its advantages and disadvantages, according to Chow. She noted that the scenario of one or two massive strikes requires non-standard conditions. Perhaps the impact led to the evaporation of these elements, but they condensed again on the surface of Mercury. Another explanation is that volatile substances come from the depths of the planet, and after the collision, they were released in the form of gases. Therefore, Chow and her colleagues modeled three different impact scenarios: a direct impact, a blow at an acute angle, and several impacts from small objects. Scientists found that each case was complicated, but in its own way. At the early stage of the formation of planets, many more than 8 nuclei emerged, which eventually became the planets of the solar system. These objects and their younger brothers flew all over the solar system and collided with each other. Scientists believe that one of these objects crashed into the young Earth. As a result of this event, the moon appeared. The necessary conditions for the implementation of the scenario of multiple impacts are more plausible, but at the moment we don't have enough information to prefer one scenario to another, said Chow. Since both scenarios implement extremely unlikely events, this means that the metal-rich worlds, such as the planet Mercury, are probably quite rare in the universe. So was this planet created to provide future colonists with ice and metal-rich deposits? My question. But how hard it is to get there? And are human beings the intended recipients of the water and the metals of Mercury? Look, Mercury is the planet closest to the Sun in our system, and the least studied among the planets of the terrestrial group. Why? Yes, it's just very difficult to fly there. Our Sun, with its monstrous gravity, greatly affects all objects that are trying to get to Mercury. To date, in fact, only 2 space probes have worked near this planet. These are the automatic interplanetary stations Mariner 10 and Messenger. Both belong to NASA. The planet Mercury is full of mysteries. One of them is, why is such a small cosmic body, which is about 2.6 times smaller than Earth in diameter, so dense? The fact became apparent after the NASA probes worked in Mercury orbit. Mariner 10 worked near the planet closest to the Sun in the years 1974-1975, and Messenger from 2008 to 2015. Thanks to the data obtained from this probes, scientists have established that Mercury has an average density of 5.43 grams per cubic centimeter. For comparison, the average density of the Earth is 5.52 grams per cubic centimeter. This means that the planet must contain a high percentage of iron, because the material of its rocky surface is much less dense than its average density. And so the researchers have reasonably assumed that Mercury has a massive and large metal core, which probably in its size reaches more than 80% of the full diameter of Mercury. So I want to ask, what if Mercury is also, like Phobos, an artificial body? No other inner planet in the solar system has such a core, in the sense that it makes up such a large proportion of its internal part. So why did Mercury's core turn out to be exactly like this? Well, let's ask the scientists. There are, of course, several assumptions on this core, and one of them is in the nascent protoplanetary nebula, gas resistance affected bodies that were richer in stony silicate materials, or rocky silicate material, and this influence was greater than the influence on metal-rich bodies. This produced a sort of sorting of the original planetesimals. This refers to any of the innumerable small bodies thought to have orbited the Sun during the formation of the planets, and those of them that were denser and heavier turned out to be closer to the Sun, and Mercury was eventually formed from them. The same planetesimals that were lighter ended up in more distant orbits. They turned out to be lighter planets. But there are other assumptions. Some scientists believe that this was not the case at all, and that during the early active phase of the young Sun, most of the rocky surface of Mercury simply evaporated. Such a process would result in fewer of the more volatile elements produced by the radioactive decay, such as uranium and potassium on Mercury's surface, smaller compared to the number of elements that are harder to evaporate, such, for example, as thorium. However, the gamma spectrometer of the Messenger probe did not detect the alleged imbalances, and this hypothesis was rejected. There is a third hypothesis. Some researchers suggest that Mercury may have experienced a giant collision at the very beginning of its history, similar to the one that, according to many scientists, formed our Moon. Such an impact could throw most of the rocky surface into space, leaving behind a planet rich in metals. A fourth hypothesis has recently appeared. In one of the studies conducted by the Japanese scientists, it is said that the core of Mercury has such dimensions due to the influence of the magnetic field of the Sun. It's just that at the time of the formation of the planets, metal particles were exposed to it, and they were distributed in such a way that more metals were closer to the Sun. And again, my hypothesis is that a super civilization, we can only imagine what it is, but I don't think we're capable of even guessing anything about it correctly. But I do guess that to hide something valuable for the future use containing metal and water, you do it in a closest to the point in our solar system that is the hardest to reach, and that would be the Sun, and away from possibilities for any young sentient civilization to reach it. But I think we're making good strides. And I think the more we learn about Mercury, Pluto, and of course Phobos and Venus, the more chances to find alien presence in our solar system we have. But we don't know enough about the Mercury as yet. Let's wait until the year 2025. I hope I gave you enough to think about and do your own research. Our solar system, the more we learn about it, the more mysterious it becomes. If you can support my research, please find the links in the description to this video. I'll continue bringing you interesting stories about our solar system and space exploration that you may not be aware about. And please subscribe to my channel. Please tell others. And please like my channel. And thank you.